Okay, so we are starting on the Test 4 review assignment out of Pearson. This hopefully will help you study for your tests. Let's start with question 1. A right triangle is given with theta as the angle. Right, it's kind of small over there. Evaluate the 6 trig functions of the acute angle. Okay, so if you remember, we have this memory peg. Let's see, sorry, that's an H. SOHCAHTOA. It's just a way to remember. That means the sine represents opposite over hypotenuse of a triangle. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, and it is important to remember the reciprocals of certain trig functions. Sine and cosecant go together, right? So cosecant, you just flip it. Right, we took the sine right here, right, and we flipped it, okay? Same thing with the cosine and secant, so let's flip it. That'd be hypotenuse over adjacent. And finally, tangent and cotangent, adjacent over opposite. Okay, so we have, those are the formulas. We just have to have all 3 sides of the angle. Okay, so I'm going to make this a little bit bigger so we can see. Well, I guess we'll look at this. You've got this right triangle, and you notice you only have 2 sides. We're missing the hypotenuse, which is the long side. Right, the longer side, it's the side that's across from the right triangle, and we need to find it. And if you remember, we're going to use the Pythagorean Theorem to help us find it. So use Pythagorean Theorem. Sorry, this is a little messy. It's hard to write with the stylus. Pythagorean Theorem. Okay, and if you remember what this says, you can take, of a right triangle, you can take the 2 shorter sides. That would be 15 squared, right, plus 20 squared. That should equal the length of the long side, the hypotenuse squared. We can do this, and we can solve for hypotenuse. So 15 squared is 225. 20 squared is 400. Right, that gives us 625 equals the hypotenuse squared. All right, so now we can use the square root property where we take the square root of both sides, positive and negative. That gives us 25, positive and negative, equals hypotenuse. But now remember, we're talking about the length of a side, so we never have a negative length. So our hypotenuse is 25. All right, so we can go put that right up here, 25. Okay, so if you look at this little triangle, I know it's tiny, but from the angle theta, the opposite side is the side that is opposite, right, from the angle. We know the hypotenuse is the long side, and then the adjacent would be the other. So now we just fill it in. So let's go over here. Sine is opposite over adjacent. Remember, opposite is 15. Opposite over hypotenuse. The hypotenuse is 25. All right, and we need to reduce that. We can take a 5 out of each. That would give me 3/5. There. Cosine is adjacent. Adjacent is 20. 25. And reduce it, taking a 5 out. 4/5. Okay, tangent. Opposite over adjacent, which is 3/4. Okay, once you have those 3, the others are pretty easy. Remember, sine and cosecant are reciprocals, so you can just flip the sine. Secant and cosine can flip. And same thing with cotangent and tangent. So these are the 6 values they want. So this question on the test will have six parts to it. So you want to make sure you take the time to get the right sides correct. And then once you have those, you can enter in your values for your trig values. Okay, number 2. This is just like the last one. So let's fill in before we start. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. opposite over adjacent, and then we flip. I'll go ahead and fill this out. It works just like the last one. Okay, remember that came from our SOHCAHTOA. Okay, so here, I'm going to write this a little bit bigger just for me. Okay, we have our hypotenuse here, right? That is the hypotenuse. Our theta, they have right up here. So our opposite is what we're looking for. I'm going to denote it like that. Okay, and we have our adjacent, 30. That is our adjacent. Okay, so we're using Pythagorean Theorem again. Okay, Pythagorean Theorem. Okay, I'll just abbreviate that, Pythagorean. Okay, our two smaller sides. So we have 30 squared plus the opposite squared. It should equal the hypotenuse squared. Okay, 30 squared is 900. 34 squared is, let's see, 1156. All right, so let's solve for the opposite side. I'm going to subtract 900 over to the other side. That leaves me with 256. So opposite squared equals 256. And here we are again. We can take the square root of both sides, right? So my opposite equals 16. Okay, so let's go up here. We have the opposite equals 16. So I'm not sure the best way. So hypotenuse, adjacent, opposite. I know it's kind of crammed together, but that gives us enough to be able to fill into our formula. Okay, over here, sine is opposite over hypotenuse. That would be 16, and hypotenuse is 34. All right, that reduces, you can take a 2 out of 16 and get 8, and a 2 out of 34, what does that give you, 17? So 8/17. Cosine adjacent is 30 over 34. Let's take a 2 out, and that gives me 15/17. Tangent opposite over adjacent, 16 over 30. Take a 2 out, 8/15. Okay, so here we have sine, cosine, and tangent, and now we can find the other three just by flipping. So sine and cosecant are reciprocals, so that would be 17/8. Secant and cosine, and finally cotangent and tangent, so flip that. There we go. Okay, for these next few problems that we have, they're asking us to find the exact value without using a calculator. You know, we're not allowed to use a calculator on the test. So what I would suggest, there's different ways of doing this, but what I've suggested to y'all is using the unit circle. So I put a very small picture on here just so we have one to look at, but that you can use the unit circle to help you. So what you want to do in this case, if I want to know where the sine of 3 pi over 4 is, let's find 3 pi over 4. I'm going to zoom in a little bit so we can do this and see it a little better. Let's find 3 pi over 4. Right here, 3 pi over 4. Okay, remember on the unit circle, for each angle we have a point. Okay, and in this point, the first value is always represented the cosine, and the second one represents the sine. Okay, so it's a quick way to find cosine and sine. So the sine of 3 pi over 4 would be square root of 2 over 2. So I'll fill that in, square root of 2 over 2. That's what they're looking for. All right, number 4, let's look for the cosine of 2 pi over 3. I'm going to zoom in again, cosine of 2 pi over 3. Let's find it. So we know a second quadrant angle, then if you notice the numerator is 1 less than the denominator, 2 pi over 3. That's second quadrant. We're looking for cosine, and remember for the points, cosine comes first. So our cosine in this case is -1/2. That's all they're asking for. Okay, for this one, they're asking for the cosecant of 3 pi over 4. Okay, now, with cosecant, now our unit circle, we can look at it and tell sine and cosine. Whenever they're asking for cosecant or secant or cotangent, what we want to first do is find the reciprocal that we can find easily, and then we can flip it. We know they're just, you just flip the answer. So in this case, for cosecant, we know that cosecant, let's see, cosecant of 3 pi over 4. Cosecant and sine are reciprocals. Okay, so we want to first find the sine of 3 pi over 4. Once we find that, we know that all you have to do is just flip the answer. So find that, then flip. Sorry, that's so messy. Then flip. Okay, sine of 3 pi over 4. Let's find 3 pi over 4 right here. Okay, remember cosine and sine? So our sine is square root of 2 over 2. Okay, that's the sine. So for cosecant, all you have to do, right, is flip it. For 4, we're just going to say that's 2 over the square root of 2. Okay? Now, Pearson doesn't like you to keep the answer this way. They like you to write it. When they say simplify it, they like it to be written where there's no square root in the denominator. So let's rationalize it. So to rationalize that, you can just multiply by the square root that's in the denominator. When you do that, you get 2 square root of 2. And then on the bottom, you get this, the square root of 4, which is 2. Those happen to cross out. Square root of 2 is my answer. Okay, for this one, number 6, they want to find the cotangent of 2 pi over 3. Let's zoom in. Okay, for cotangent, let's first find the tangent of 2 pi over 3, because that's the reciprocal. Okay, find that, then we can flip it. Okay, so for this, we have 2 pi over 3 right here. But remember, this point is cosine and sine, so we don't really have the tangent, but we do know that tangent is the same thing as sine over cosine. Okay, sine over cosine. So, for 2 pi over 3, my sine is the square root of 3 over 2. Right, I'm getting it right here. And my cosine is negative 1/2. Okay, so what does that give us? That gives us, we'll do it right here, square root of 3 over 2. And then we can flip it. That gives us those crossed out. We get negative square root of 3. Okay, so that's my tangent. But remember, I'm asking for cotangent. So now we need to, our cotangent of 2 pi over 3, we just need to flip it. Remember, this is negative square root of 3 over 1. So if we flip it, we would get negative 1 over square root of 3. And this is our answer. All right, number 7. Let's find the sine of negative 7 pi over 6. Okay, so we're looking at the unit circle. Our unit circle goes from 0 to 2 pi. So negative 7 pi over 6 is not on the unit circle. So when we have this angle of negative 7 pi over 6, we need to find the coterminal angle. Now remember the coterminal angle, right? The way we can find it is if we have a negative angle, we can just add a rotation to it until we get a positive angle that's somewhere in that first unit circle between 0 and 2 pi. So since it's negative 7 pi over 6, let's just add a 2 pi. Remember, we're adding because it's negative and we want to, add to make it positive. So when we do that, we do have to get common denominator. So let's convert 2 pi. If we're talking about over 6, that would be 12 pi over 6. And when we add those together, negative 7 plus 12 gives me 5 pi over 6. Okay, so coterminal angle, that means that the sine, of negative 7 pi over 6, which is what I'm asking for, is the same thing as the sine of 5 pi over 6, because negative 7 pi over 6 and 5 pi over 6, they're coterminal angles. Okay? They're really in the same place. We just added a whole circle to it. They have the same trig value. So we can find sine of 5 pi over 6. Let's find it on our unit circle. I know it's really tiny. Let's see if I can zoom in. Yeah, I'll zoom in. Where is 5 pi over 6? Let's see. 5 pi right here. Okay? The sine, remember, cosine is the first in that point. Sine is the second value. So what is it? It is 1/2. And that's our answer. Okay, number 8. This is just like the last one. They're asking for the sine of negative pi over 6. So it's negative again. So we need to find the coterminal angle. So negative pi over 6. Once again, it's negative. So we're going to add a whole rotation, which is 2 pi. Okay, let's see what we get. We have negative pi over 6. And this would convert to 12 pi over 6. So if we add those together, negative 1 pi plus 12 pi gives me 11 pi over 6. Sorry, that's so messy. Okay, so basically we're asking for the sine of, let's see, negative pi over 6 is the same as the sine of 11 pi over 6. And we want to use 11 pi over 6 because that's actually an angle on our unit circle. So let's zoom in. 11 pi over 6 we can find right here in the fourth quadrant of our unit circle. Here we have our point. Remember, cosine first, sine second. I'm asking for the sine, so my sine in this case is negative 1/2. And that's our answer. Okay, so now here we get to 9 and 10. The way these two problems are worked, we're going to use the chart, the all students take calculus chart. Okay, it's very, very helpful. And remember, what this chart does is it tells us which quadrants the trig values turn out to be positive. So quadrant, the A represents all, means every single trig value for an angle in the first quadrant is positive. The S stands for sine, of course, sine, and it's reciprocal, which is cosecant. Okay, this is positive. And then quadrant 3, the T, of course, is tangent, and its reciprocal is cotangent. And then finally, quadrant 4, the C is cosine and secant. Okay, so remember, this tells you in which quadrants the trig values are positive. Okay, so for number 9, the question says, let theta be an angle in standard position. We don't know what the angle is, but they want to see if we can figure out which quadrant it lies. And they give us 2 bits of information. First, they tell us that the sine is greater than 0, and then the cotangent is less than 0. So the way we work it is we're going to use this chart. Okay, and let's think about it. Okay, first of all, sine is greater than 0. That means that the sine of whatever this theta is positive. So you come over here and you ask, sorry, I'm not that right, no, well. Okay, so you come over here and you say, where is sine positive? Well, we know that sine is positive in the first quadrant because everything's positive in the second. Okay, and then for cotangent, cotangent is less than 0. That means negative. So we ask, okay, cotangent and tangent go together. So where are they positive? They're positive in the first and the third. Therefore, they're negative in the other ones. So second and fourth is where they're negative. Okay, your theta is in the quadrant that satisfies both. So the one with 2 checks, which is quadrant 2, right there, is your quadrant. Okay, let's look at number 10. Same thing. First, we know the tangent is greater than 0, which means positive. So let's ask ourselves, where is tangent positive? We know its tangent is positive in the first and the third. Okay, and secant is less than 0. That's a negative. So remember, secant goes with cosine. So secant and cosine. So looking at the chart, secant and cosine are positive in the first and fourth. Therefore, they're negative in second and third. All right, so theta must lie in my third quadrant, so in the third quadrant. All right, that's the answer. Okay, so here we now reach the problems where we are dealing with the inverse trig functions. For 11, we're talking about the inverse sine. Okay, so you can see it written sine to the negative 1, right? That's inverse. You can also see it written as arc sine. These two things represent the same thing. It's just two different ways of writing it. Okay, so when we get to we're going to do inverse sine, cosine, and tangent. So just remember the inverse sine, the way it's defined is we had to restrict it between just a small interval. So the interval in this case for the sine, the inverse sine, means the answers or the values that you can have for it go between negative pi over 2 and pi over 2. Okay? That's the way it is restricted. Okay? That means whenever you see the sine, inverse sine or arc sine, your answer is represented by a angle. Okay? Your answer is going to be some kind of theta, some kind of angle. Okay? And those angles are somewhere between negative pi over 2 and pi over 2. So if you remember on the video when we talked about and describing how things worked, if it's restricted between negative pi over 2 and pi over 2, right here, negative pi over 2 and pi over 2, right, that's quadrant 1 and quadrant 4. But instead of, writing the normal quadrant 4 like we're used to, we started at 0 and we went in the negative direction, okay? But that makes it kind of easy because now our angles over here, these are like pi over 6, pi over 4, and so on. And angles in quadrant 4, we're just going to write them as negative pi over 6, negative pi over 4, negative pi over 3, okay? So that's how we work it. So let's look at number 12. Find the exact value of the following expression. Okay, let's see. When we have the inverse sine, I like to rewrite it because remember, this whole thing right here, the answer is going to be some kind of theta. But if I rewrite it, it's like saying, find the theta such that the sine of theta equals 1 over square root of 2. Okay? They're wanting you to know what is the theta. All right. So what you do in this case is, and I know it's tiny, so let me zoom in just a little bit. I included my reference little chart for my reference angles, for the first quadrant reference angles. What you can do is you can look it up and say, okay, where's the sine 1 over the square root of 2? Now, we don't see it written here, but 1 over the square root of 2, if you actually rationalize that, by rationalizing it, you can rewrite it as that. So 1 over the square root of 2 and square root of 2 over 2, those are the same things, just written different ways. Okay? So they're basically asking what theta gives me the sine equals the square root of 2 over 2. That happens at pi over 4. Okay? My answer for theta is pi over 4. Okay? Because, look, this value was positive. All right? So when the value for the sine of theta is positive, that's quadrant 1, which is just the reference angle pi over 4. That's all they're looking for. There's only one value for theta as your answer, only one angle when you're dealing with inverse sine. Okay? Let's work some more. Okay, here we are. This one is very similar to the last one. This time we are looking for the inverse sine is negative 1 over square root of 2. So let's see. I'm going to rewrite it. That's the same thing as saying find the theta such that the sine of theta equals negative 1 over square root of 2. Okay, just like the last problem, we're going to rewrite that negative 1 over square root of 2. That is the same thing, right? If we rationalize it, it's saying the sine of theta equals negative square root of 2 over 2. Okay? So we're going to try to solve this. Tell me what the theta is such that this is true. Okay, so what we do is we go over here and we notice that we're going to look up square root of 2 over 2, which, let's see, would be right here. The sine of theta is square root of 2 over 2 at pi over 4. right? Just like the last problem. Here's the difference. The sine of theta is negative square root of 2 over 2. Okay, that means that my theta can't be positive. It can't be positive pi over 4. It's going to be negative. So my answer is negative pi over 4. So to summarize just really easily, you look up the reference angle, okay, and find that. If the sine equals a negative number, then you put a negative on the reference angle. That's all you have to do. The last problem, if you remember what we just worked, when we said the sine of theta equals positive square root of 2 over 2, see the difference? This time it's positive. My theta was positive square root of 4. I'm sorry, positive pi over 4. You see the difference? Negative means negative. Positive means positive. And you got the pi over 4 by looking it up on my reference chart. I hope that makes sense. That's for sine, inverse sine, and the same thing works for inverse tangent. Now, inverse cosine is different, but sine and tangent work the same way. Okay, now let's look at number 14. The inverse sine of 1. Okay, that's what we want to find. So remember, we can rewrite this. It's the same thing as saying the sine of theta equals 1. And we want to find what is my theta. Okay, so what you do here is, once again, we know it's the sine we're talking about. So we come to our reference chart right above. Where is the sine 1? Positive 1. That happens at pi over 2. So my answer, my theta, is pi over 2. Okay, 15 and 16, we are looking at inverse tangent. So like I just mentioned in the last problem, when we're talking about inverse, inverse sine and inverse tangent work the same way, in the sense that the value of the angle is going to be somewhere between, let's see, negative pi over 2 and pi over 2. The difference in this is you have parentheses. You actually can't have pi over 2 or negative pi over 2 as an answer, because for tangent at those angles it's undefined. Like real quick, just look down at the very far bottom left hand chart. If you looked up pi over 2, right, and tangent is undefined. Okay, so in a sense, we would never have pi over 2 or negative pi over 2 as a possible answer when we're talking about tangent. Okay, that's why we put parentheses instead of brackets. Okay, but nevertheless, let's work number 16. They want you to know, tell me what's the inverse tangent of 1 over the square root of 3. So I like to rewrite it. You don't have to rewrite it, but I like to rewrite it this way. Tangent of theta equals 1 over square root of 3. Okay, so we want to find theta. All you have to do, right, is you come over and you look up where is 1 over square root of 3. And my little reference chart down here will tell us. I know it's really small, but you can still find it. The tangent at 1 over square root of 3 happens at pi over 6. So my theta is pi over 6. Since this was positive, my theta is positive. Right? And that is my answer. Just to show you, if I had had the tangent of theta equals negative 1 over square root of pi over 3, my theta would have been negative pi over 6. That's all you have to do. Find the reference angle, and you carry the positive or the negative with it. All right, let's look at number 17. Let's find the inverse tangent of negative square root of 3. So I'm going to rewrite it. That's the same thing as saying the tangent of theta, negative square root of 3. Okay, we are trying to find, my goal is, what is theta? Okay. All right. So remember what we say. Let's see, where is the tangent square root of 3? We'll come down in the chart at the bottom of the page. Tangent is the square root of 3, and that happens at pi over 3. So my reference angle is pi over 3. Okay? But because this was negative square root of 3, that happens at negative pi over 3. Remember, the negative carries with it. That is my answer. Let's look at 18. The tangent inverse, we just know my answer is going to be a theta. When you see inverse, you know like when you see tangent to the -1. And remember, you could see it written as arctangent. That's the same thing. You know that my answer is going to be a theta. Okay, it's going to be some kind of angle. So let's rewrite it. The tangent of theta equals -1. All right, so let's come down to our chart. Where is the tangent? 1, well, tangent is 1 at pi/4. So that's my reference angle. But because this was -1, it's -pi/4. To me, that's pretty easy. As long as you know what you're looking for, it's pretty easy. And that, once again, that happens with inverse sine and inverse tangent. You just find the reference angle, and you're either going to keep it positive or you're going to put a negative on it. That's it. Okay, so our last kind, which is cosine, I said the inverse cosine is the only one that's different. The inverse cosine is different because we can't restrict it from negative to positive pi/2. We have to restrict it from 0 to pi. 0 to pi, which means if you were looking on the unit circle, you have to restrict it between those angles, 0 to pi. And the reason we do that is because you have to have one quadrant that represents positive angles, or trig functions, and one quadrant that represents negative trig functions. So we know that quadrant 1 for cosine, quadrant 1 is positive, quadrant 2 is negative. Quadrant 4 down here is positive. So that's why we can't do quadrant 1 and quadrant 4 like we did for inverse sine and inverse tangent. Okay, so we're sticking to only quad 1 and quad 2. So the only where it's really kind of different is, if we have the inverse cosine of a positive value, that's just a first quadrant angle, very simple. But when it's a negative, we have to write it as a quad 2 angle. So let's just work some problems. Here we go. We have inverse cosine of 1 over square root of 2. So let's rewrite it. Cosine of theta is 1 over square root of 2. Okay, so just like before, my chart that I have it listed as the square root of 2 over 2, which, remember, if you rationalize it, you could write it square root of 2 over 2. Okay, those are the same things. It's just nice if you kind of know that's the case. So I'm basically saying what theta gives me the cosine equals square root of 2 over 2. So you come over here, cosine, right here. Square root of 2 over 2 happens at pi/4. So my theta is pi/4 because it was positive, right? So it's just my positive reference angle. So when all the numbers are positive, everything's easy. You just have your positive reference angle. Okay? Let's look at inverse cosine of negative square root of 3 over 2. All right. So this is, if we rewrote it, it's the same thing as this. We're looking for theta that gives me the cosine of theta equals negative square root of 3 over 2. This is the part that is different from all the others. Okay, because notice this is negative square root of 3 over 2, right? So to look it up, we need to find the reference angle. So come down to our chart. Where is the cosine square root of 3 over 2? And that happens at pi/6. Okay, you just use your chart. So I'll put it down here. Okay, my reference is pi/6. But that's when it's positive. But when it's negative, if you think about it, remember this is my chart. My cosine goes between quadrant 1 and quadrant 2. That's pi/6. Okay. The cosine of that is positive square root of 3 over 2. When I want it to be a negative, right, it happens over here in quadrant 2. This is not negative pi/6. We have to write it as quad 2. And so that angle, we know, is in quadrant 2. Right, there's my reference angle, but quad 2 angle is 1 less on top than the bottom, 5 pi/6. So that's your quadrant 2 angle that has the reference angle pi/6. That's my answer. Let's look at number 22. Inverse cosine equals 1. So rewrite it. We're looking for theta. Okay, where is the cosine 1? Let me erase just to make it a little bit easier for us. Okay, where is the cosine 1? So cosine is 1 at 0, right? That's pretty easy. 0. So my theta equals 0. Okay, so after going over all of the inverse tangents and inverse sines and cosines, now we have a couple of problems where they're actually putting both operations together. So when you see something like this, it looks so confusing, but what you need to do is just work inside out. Okay, so we're going to work right inside first. Let me find a good place to do it. Why don't I do it down here? So we have the sine, and the first thing we're going to look at is the inverse tangent. This is what we just were doing, okay? So let's do this first. We know this is a theta, and we need to figure out what it is. Every time you have an inverse trig function, you know your answer is some kind of angle. So remember how we do it? You don't have to rewrite it if you don't want to, but it's like saying, tell me the theta that gives me 1 over square root of 3. So we say, where is the tangent 1 over square root of 3? It happens at pi over 6. Right? And because it was positive 1 over square root of 3, it's positive pi over 6. So that's what's inside that first parenthesis. Now we can find the sine. Okay? So find the sine of pi over 6. This is what we did back in a couple of previous sections, that we can just use the unit circle. I know that is very tiny, so let's see. I'm going to bring this up here. We're trying to find the sine of pi over 6, and I'm going to zoom in so we can see it. Okay, so we just need to find the sine of pi over 6. Here's pi over 6. Remember, cosine and sine, right? So the sine of pi over 6 is 1/2. Okay, I mean, I guess you could have found it over here too, right? The sine of pi over 6. Sine of pi over 6 is 1/2. So these are, since it was first quadrant, it happened to be first quadrant. You could have used either one of these charts to help you find the same answer. Regardless, 1/2 is my answer. Okay, this is another one just similar to the last one. We have the secant. Let's see, I'm going to rewrite it down here. The secant, right? And when you do this, we're going to work inside out. So sine of 1/2. So what we want to do is first find right there, right inside the parenthesis, it's the inverse sine. So we know I'm looking for the theta. So you basically are asking yourself, what theta gives me the sine is 1/2? So if you come up to our reference chart, the sine is 1/2. I'm sorry, 1/2, right? That happens at pi over 6. So that's pi over 6. That's what my inside, inverse sine is. So now we can find the secant of pi over 6. Okay, so find the secant of pi over 6. We know that my unit circle and this reference chart only gives me sine, cosine, and tangent, not secant. So what we have to do in this case, if we have to find the reciprocal, let's see, secant and cosine go together. So let's find the cosine, right? Then all we have to do is flip it. Okay? So let's find cosine of pi over 6 first, then flip. Okay, and once again, because pi over 6 is a first quadrant angle, you can use either the unit circle or my reference guide. It doesn't matter. If I look at my reference guide, the cosine of pi over 6 is right here, square root of 3 over 2. By the way, if you look, I'm going to zoom in. By the way, if you looked on this, pi over 6, remember, cosine is the first value, which is square root of 3 over 2. Two different places that you can find the same value, okay? So cosine of pi over 6 is square root of 3 over 2. But we're asking for, let me zoom back out, we want to know what the secant of pi over 6 is. So we have to flip. So if we flip it, It's 2 over square root of 3. And this is our answer. Okay, so now we get to ones where it says rewrite the trig expressions as an algebraic expression involving the variable u. Okay, expect to see one of these on the test, and you kind of know that you're at this kind of problem because of the directions. They're asking you to write it as an algebraic expression. So what we're going to do is we're going to rewrite this and try to put it on a right triangle. Okay, so let's look at it. We have cosine. Let's work inside out. So let's take inside this triangle, inside this parenthesis, we have the inverse sine is 3u, okay? So I'm going to rewrite that. That's the same thing as saying that the sine of theta equals 3 over u, okay? That's what that is. So what we're going to do is we know that the sine is opposite over hypotenuse. Remember, SOHCAHTOA, sine is opposite over hypotenuse. So we can write, if we put this on a triangle, because we're doing an algebraic expression, so we're going to put it on a triangle, a right triangle. If this is my theta, okay, the opposite is the opposite side. That would be 3. And the hypotenuse is u. Remember, hypotenuse is always the long side that's across from the right triangle. The right angle. So we have that. So we need to find the adjacent side. And we're just going to do that using the Pythagorean Theorem. Okay, so if you remember Pythagorean Theorem, you do the two small sides, right? Pythagorean Theorem. That says the adjacent squared plus 3 squared should equal u squared. And let's solve for the adjacent. We don't know what u is, but we're just putting it in algebraic terms. All right, that's 9. Okay, finally, we can square root. Once again, we're talking about length of a side, so we don't need to do the minus. We just need the positive value. So a equals square root of u squared minus 9. That is my adjacent. Let's see, right. That's not the final answer. My adjacent is that. Now that we have all 3 sides, now we can sit over here back to the original problem and find the cosine of theta, right? And because remember, this inverse sine right here is a theta, right there. It's theta. So the cosine of theta, we know that cosine is adjacent over hypotenuse. All right, so C-A-H. So what is that? Let's see. Adjacent is this. Over the hypotenuse is u. That is my answer. It's just written in an algebraic terms. Okay, there's no solving. It's just written. Okay, here we have another one just like the one before. Rewrite the trig expression as an algebraic. Okay, so here we are. We have tangent. We're going to work inside out. So take inside the parentheses. Okay, right here. And we're going to rewrite it. That's saying the same as saying the cosine of theta equals 4u. Okay, and we're going to put this on a right triangle where we have theta. So we know that cosine is adjacent over hypotenuse. So you can rewrite it that way. Cosine is 4u over 1. Okay, so if we, on our triangle, the opposite, that's opposite right there. The adjacent would be right next to it here. The hypotenuse is 1. We need to find the opposite side using Pythagorean Theorem. So let's say we have 4u squared. Be careful here. It's 4u, all of that squared, plus the opposite squared, should equal 1 squared. Okay, one of the most common mistakes is right here, this 4u squared, is they don't put parentheses on it, and a lot of people want to write that is 4u squared, but it's not. It's 16u squared, because you square everything. Square the 4 and the u. That's just a careless mistake. Okay, so we have opposite squared. There. Finally, square root of both sides. We get the opposite side, 1 minus 16u squared. Okay, that's right here. And now, once we have all three sides, we can write the tangent, right? Tangent. Remember, this is theta. So remember what tangent is? It's opposite over adjacent. Opposite over adjacent. So the tangent of theta, the opposite side is this, and the adjacent is 4u. That is my answer, opposite over adjacent. Okay, 27 through 30 or 31, these come from section 8.1, and we only asked just a few questions about the trig identities. And in my notes, we've listed a lot of the trig identities. They just want you to fill in the blank. So, number 27, tangent is sine over what? We know by definition, tangent is sine over cosine of theta, right there. Complete the quotient identity. This is just like the other, because what equals sine over cosine? That would be tangent. They're just wanting you to go over some of the identities. But our section 8.1, I've listed all these for you. Complete the reciprocal. Okay, these are these reciprocals that we've been talking about a lot. We know that cosine, right, and secant go together. So cosine is the same as 1 over secant. Okay, that's the way you write it when you flip something. The reciprocal is like putting it over 1. Putting it 1 over that. Okay, and then complete the reciprocal here. 1 over cosecant. Well, cosecant and sine, right, they're reciprocals. So the answer would be sine. Okay. Okay, and number 31, this is one of the Pythagorean identities. And it says 1 plus tangent squared, okay, equals secant squared. That's just one of the Pythagorean identities. The other ones, by the way, you have 1 plus cotangent squared equals cosecant squared. That's one of them. All right, and then the other one from the beginning is sine squared plus cosine squared equals 1. So these are 3 Pythagorean identities. Or really, the main one is this one right here. And then you can derive the other 2 from that. It's listed in our 8.1 notes. Those are just important identities when you're talking about trig. All right, we are almost done. We are at the end with the last 3 problems. This is the very last material that we're doing or covering. And this is when we're solving these equations, trig equations, find the specific solutions. Okay, the key here is that the answers are between 0 and 2 pi. So remember, 0 and 2 pi is basically saying the whole unit circle, okay, which means they're going to be asking us to find certain angles that solve these equations. And the angles, a lot of times you can get multiple angles as your answer. And they come from different quadrants in the unit circle. Okay, we just have to take that to account. So let's look at the first one. We have the tangent of theta. This equals 0. Okay, so the way we want to approach it, we approach it like an equation. We treat tangent of theta the same way we treat an x when we're solving an equation. We want to solve this in terms of tangent of theta equals some number. So I can do that pretty easily by saying I'm going to subtract that to the other side. And I get the tangent of theta equals negative square root of 3. Okay, I went ahead and filled out my little reference guide for us because I don't actually have it on the page already, but we can use it. So once we get here, we want to know what theta will solve this equation. So what values of theta, when I plug it into the tangent, gives me negative square root of 3. So what you need to do is we're going to come over and we have to ask ourselves, where is the tangent? Where do I get a negative value? Remember, all students take calculus. We know that tangent is positive in the first and the third. Therefore, it is negative in second and fourth. And since the tangent is negative square root of 3, then I know my theta has to be a quadrant 2 angle and a quadrant 4 angle. Okay? Because we're looking for values that give us negative, right? So to get quadrant 2, quadrant 4, all you have to do is look up the reference angle on our chart up here, okay? And that's square root of 3, so where's the tangent? Square root of 3 right here. And that happens at pi over 3. Okay, that's my reference angle. Pi over 3 is actually a first quadrant angle. So to write a quadrant 2 angle, we use pi over 3. And so remember, the quadrant 2 angle is 2 pi over 3. The numerator is 1 less than the denominator. That's quadrant 2. And then quadrant 4, just our little memory peg, you can double the denominator and get 6. Take away 1, 5. So we have two possible values for theta. 2 pi over 3 and 5 pi over 3. Okay? Don't mix this up with the inverse tangent that we had. When you're doing inverse trig functions, which is like tangent to the negative 1, you can only get one value for your answer. This one, you can get multiple values since we are talking about the whole unit circle and all 4 quadrants. Okay, let's look at this one. We have 6 cosecant of theta minus 4 equals 2. Okay, we want to solve it. And remember, the cosecant of theta right here, we treat that just like we would treat an x if we're solving an equation. So let's get this by itself. So I'll start by adding 4 to both sides. I get 6. Cosecant of theta equals 6. And now let's divide out 6 right here. We get cosecant of theta equals 1. That's our goal here, is to get just the trig value by itself on one side. So cosecant of theta equals 1. So we have to ask ourselves, what are my thetas? Okay, but now our reference chart over here, remember, only has sine, cosine, and tangent on it. So let's rewrite our cosecant in terms of its reciprocal. Cosecant and sine go together. All right, so if cosecant is 1 over 1, you flip it and you get 1 over 1 again. So we're basically looking for what thetas give me sine of theta equals 1. Okay, now remember, if you go back and you look at the directions for these questions, your answers go from 0 to 2 pi, which means you have to take into account the whole unit circle. Okay, so let's look at the unit circle. I don't have it written down, but if you remember, and you can look at the unit circle or you can jot this down. You know, if you look at our reference chart, the sine of theta is 1 right here at pi over 2, right? But we want to make sure there's not any other angles, so let's check ourselves. So we have 0. Just on the xy axis, we have pi over 2, pi, and 3 pi over 2. Okay, so on the unit circle, if you were to look at the points, here, this is the point 1, 0. Up here, we went over 0 and up 1. Over here at pi, we went over to the left, negative 1, up 0. And finally, down at 3 pi over 2, we went over 0, down 1. Right there. So there's our points. This is what happens when you're looking on the xy axis and you're not in between, actually inside the quadrants. So let's just check and make sure. Remember, each point The first value is the cosine, the second is the sine. So where is sine 1? Well, right here, that works because that's at pi over 2. And down here at 3 pi over 2, it's negative 1, so that doesn't work. So we actually only have one place that the sine equals 1. That happens at pi over 2. And that's my answer. Okay, let's look at this one. We are wanting to solve the tangent squared of theta equals 3. Okay, so we're solving its tangent squared. That's the same thing if we were trying to solve an equation if we had x squared. So to get rid of the squared, we can square root both sides. So I'm going to use the square root property, right? You take the square root of both sides. You cannot forget to do plus and minus. So we basically have the square root of tangent squared just gives me tangent. And I have plus and minus square root of 3. All right, so that means we can set up two equations. The tangent of theta equals positive square root of 3, and the tangent of theta equals negative square root of 3. And we just have to solve each one of those. My answer is everything put together. So let's first look at the tangent of theta equals positive square root of 3. So when we're thinking about tangent, let's see, tangent is positive in the first and third and negative in the second and fourth. Okay, so for this one, since it's positive square root of 3, we know that my theta has to be positive, which would be quadrant 1 over here and quadrant 3 over there in quadrant 3. Okay, so let's look it up. Let's look at our reference angle. Where's the tangent, the square root of 3? That happens at pi over 3. So my quadrant 1 angle is pi over 3. That's just quadrant 1. Quadrant 3, we're still going to use my reference angle pi over 3, but for quadrant 3, that would be 4 pi over 3. Right, so that solves the first one. And then for the second one, this is kind of the same thing, except this time is where's the tangent negative. So that would be the other two quadrants, right? So we have a quadrant 2, right, and a quadrant 4. So we know the square root of 3, the reference angle is pi over 3, but for the quadrant 2, that would be 2 pi over 3. Remember, quadrant 2, you have one less on the top than the bottom, so 2 over 3. And then for quadrant 4, remember our little memory peg, double the denominator, which you get 6, take away 1, 5. So my answer for this is all 4 angles, all 4 of them. Okay, finally we're to the last problem. So we have, this one looks kind of weird because we have a sine and a cosine. Right? And remember, we're trying to solve in terms of one trig function, like either sine equals or cosine equals. So for this one, if you notice, we know that if you were to divide both sides by cosine, because we know that sine over cosine is tangent, we can do that, right? So we would get 5, and then sine over cosine is tangent, which is nice. Okay, we want tangent by itself, so let's divide both sides by 5. We get the tangent of theta equals negative 1. And this is what we want to solve. So once again, for tangent, tangent is positive in first and third, negative in second and fourth. And I'm looking for where's the tangent negative 1. So that would be quadrant 2 and quadrant 4, because those are the two negative ones, right? Okay, so let's look it up. Where's the tangent 1? In my reference chart, tangent is 1 at pi over 4. Right, tangent 1 pi over, so we have pi over 4. Okay, that's my reference angle. That's not my quadrant 2 angle. That's a quadrant 1 angle. So let's write it as quadrant 2. That would be 3 pi over 4. Right, and then quadrant 4, once again, double the denominator. You get 8. Take away 1. That's a 7. That's my answer. Okay, I hope this makes sense. That is going through this whole review assignment, and I realize yours might have some some different questions, so it's good to work through the one you have in Pearson also. But hopefully this will be a good guide for you to help you work through it and prepare for your test.